So we just took a test yesterday, and yesterday's test was all about quadratics, and we were graphing quadratics and we were factoring quadratics as the main points of focus. As we move on from here, we're actually going to be continuing with the quadratic theme. It's actually the second half of Unit 4. And so we're still going to be working a lot with the quadratics, a lot with x squareds. So all those skills that you were just tested on, oh yeah, they're definitely going to keep rolling forward here, as you're going to be seeing today. For the first thing we're doing is we're going to be looking at how to solve equations, specifically solving equations that involve quadratics. Now I want to start by taking a look at how we could go about doing this particular one. Because I'm solving a system of equations, and we solved systems of linear equations earlier this year. And so let's take a look at what we could do. By the way, you don't need to write this down yet. You will be writing down the system in a minute, but you don't need to write down this work because we're kind of exploring here at the moment. So earlier when we saw systems of equations like this, if we went to solve them, we might use substitution or elimination. Now, this does not look like it would be set up nicely for elimination to me. So I don't want to use elimination here by adding those straight down. But substitution, it looks like it might be reasonable. If I did that by substitution, I'd end up with 1/2 x squared minus 4x equals 10. And then I'd be trying to solve that. But this one actually ends up being a little bit tricky to solve algebraically. Because, for instance, some people will look at it as, well, what if I move the 4x over here? Well, you still have an x squared and an x. Could I just take the square root? Could I just do this? Well, yes and no. Technically, you are allowed to take the square root, but if I took the square root of that left side, I'd actually have to take the square root of the whole 1/2 x minus 4x, and that would be really complicated to do. There's actually a lot of details in there. I can't just turn it into this. That does not work because of that subtraction between them. And so if I did move that 4x over, though, you might be wondering, well, what if I did that? Couldn't I then take the square root? Well, it'd be a lot easier to take the square root of this side, but now notice you'd be trying to take the square root of that, 4x plus 10, which again is one of those very ugly, complicated things to take a square root of. It does not just work out to be the square root of 4 and the square root of 10. So because of the fact that we have both the x squared and the x in here, we can't actually solve this algebraically, at least not yet. Here within a week or two, you will be able to, but we're going to have to see those techniques. But already, before we even get to those, you do already have a technique that would let you solve this. Because when we solved the systems before, we solved by elimination, we solved by substitution, and we solved by what? Graphing. And so, can I graph each of these two equations? Yes. And so that's what we're going to do. We can solve this system by graphing both equations and then just looking to see where they intersect. So this is why you set up those graphing grids. So go ahead and write down the system above your first graphing grid, and then graph the first equation, graph the second equation. Now, if you're getting thrown off by that first one at all, it is a quadratic in standard form. There's no c value. C is 0, but you still have a and b, so you can still plug those into our formula to find the location of the vertex. So when you go to find that vertex, you're using x equals negative b over 2a. Should have that memorized still from the test we just took, but if not, get it memorized. It's going to keep coming back. That's not one of those things that you can remember for a week and then forget about. And so then we plug in our values here, so it's going to be a negative 4 on top over 2 times a half. And that one always makes life a little bit easier for us, because that ends up giving us a negative 4 over 1. Well, of course, negative 4 over 1 just equals a negative 4. And a negative 4, well, that's just 4. So make sure you got x equals 4, and then go ahead and find your y coordinate if you haven't yet. And so when you plug the 4 back into that original equation, we end up finding that y equals -8. So we know our vertex is at 4, -8, plot that point, and then we make our graph from there. Now notice from making our graph, we have an a value here of 1/2. So as I plot my points, that's a vertical compression by a factor of 1/2. So I'm only going to go up half as far each time. So over 1 up 1 becomes over 1 up 1/2. Over 2 up 4 becomes over 2 up 2. Over 3 up 9 becomes over 3 up 4.5, because whatever I normally go up, I multiply it by that 1/2. And just keep plotting all of the points that are going to fit. And yes, it's critical that you plot every point that fits on our graphing grid here. And so when you plot all those points, these are all of the points that fit on there. So you can make sure you got all of them in the right spots. And so then we can go ahead and draw the curve that goes through that, and we have our first graph done. But then we have to deal with the second graph. There we got y equals 10. And so we have to remember what that graph looks like. And normally at this point, there's 2 different options that I'll see. One option is that I'll see, well actually, just about everybody will put the first point at 0, 10. But it's a matter of where we go from there, because I'll see some where they'll draw it with a slope of 1 from there. So it's a slanted line. And I'll see others who will draw it with a slope of 0, which means that it's a horizontal line. Now, which of these is correct? Well, notice that it's y equals 10. There's no x in there. If there were an x in there, then it would be slanted with a slope of 1 or whatever other number might be in front of it. Because there's no x in there, that means it's like a 0x, which means our slope is 0. So yes, it is just the horizontal line. And so then this is what our graph should look like. And as a little refresher, a little bit of reminder, why is that the graph of y equals 10? Notice that every single point, no matter what I pick on that graph, the x-coordinate is changing, but the y-coordinate never does. The y-coordinate there is always 10, hence y equals 10. All right, now, that was the hard work of this, but I'm still not done. Remember, we are asked to solve the system, so we still have to give the solution. So I look to see where they cross, and you'll notice in this case, they do cross twice. We saw that happen before when we solved systems with absolute value. Same kind of an idea here. And so I'm going to give both of those solutions. Now, you'll notice that my original system here, it had x and y in it. Therefore, my answer will also be comprised of x's and y's. Since there's 2 points, I'm actually going to list both of them as coordinate pairs. So this first point was at -2, 10, and the point on the right was at 10, 10. So that's how I write my answer. -2, 10, comma, 10, 10. As you type this kind of an answer into wall map, that's exactly what you'll do. You do -2, comma, 10 in parentheses because it's a point, then put a comma to separate with the other one. When you do it in wall map, of course, it's all one line. Here it's on 2 lines just so it doesn't bleed into the graphing grid. All right, so this one's done. That means that we can then on something that looks like this. And again, we're looking how to solve it. But this one looks a little different, right? In this case, this is just one big old equation. Yet, we actually can use the same techniques that we already know. Because I want to be able to figure out basically what makes this absolute value equal this quadratic. Well, again, algebraically, this could be a challenge. If you thought a quadratic equals to 10 was challenging, imagine a quadratic set equal to the absolute value. That's even worse. So, we're going to approach this one similarly. We are going to graph it in order to solve it, and in order to graph it, I can't graph like that whole thing just as you see it, so we break it up into 2 pieces. We break it up into y equals the left side of the equation, and y equals the right side of the equation. That way we can graph both of those as 2 separate equations, then look to see where they cross. So, that's what we're going to do. Write this problem down, of course, above your second graphing grid. Write down the work where we break it up into the 2 separate equations, and then go ahead and graph both equations, please. Now, of course, for making that first graph, hopefully that's fairly straightforward because we don't need to do any actual math there. We just have to look at it and know that the plus 5 means left 5 and the minus 3 means down 3, so we plot that point. And then it's our normal absolute value, up 1 over 1 on both sides from there to make our v. The second graph, it requires more work because you actually have to find the vertex there, because again, it's a quadratic in standard form. So that tells us right away that we're going to x equals the negative b over 2a, and we're plugging in for that. In this case, that means it's going to be a negative 2 over 2 times 1, because remember, x squared is the same as 1x squared, so a is 1 there. So then we can know that x equals 1. So the x-coordinate of our vertex is going to be a positive 1. Plug that back into your original equation to figure out then what your y-coordinate is. You should find that it's at negative 9. So we plot that point at 1, negative 9. And in this case, there's no stretch because our a value is 1. So it's just our normal over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16, etc. Plot every point that fits on there. And as you do so, you'll probably find that you plotted a couple of those points right on your absolute value graph, right? Well, those are going to be the ones we're interested in. Because I want to know, again, I made the graph so that I could solve it. I made the graph so I could see where do they intersect. But our answer is going to look a little different this time. My answer in this case will not be coordinate pairs. And the reason is the difference between how this problem and the last problem were set up. In the last problem, remember that I had two equations that were both y equals something with x. So we started out with x and y. In this problem, I'm not starting off with x and y. Remember that this was actually what I started with up here. You notice that that only has x in it. I'm making the graph so I can figure out what x equals. The only reason why I have any y's over here is because I put them in order to be able to make the graphs. So when we give our answers here, we're only saying then what x equals. So what is the x coordinate of our left point? Negative 2. And then what is the x coordinate of our right point? Remember, I only want the x coordinate, so it's 5. And so then this is my final answer here, is that x equals a negative 2 and a 5. And that's it. No y values here. And because there's no y values, there's no parentheses. I'm just listing out the possible answers.